Hi, today we're looking at integration by parts. Now, most of the time when we're doing integration by parts, we have two different types of functions occurring. So we'll have a logarithmic, inverse, polynomial, exponential, or trigonometric. So we've got two out of that. Now, it takes the form of our integral of u times v prime dx is equal to uv minus the integral of u prime v d of x. And our order of which one we take as u versus v prime is based off of a sliding scale here. So typically we'll have two functions. So for example, if we have, say, an inverse trig and an exponential, our inverse trig here is closer to the u than our exponential is. So that would take our value of u, while our exponential would be our v prime. Now this can be a bit hard to remember. Logarithmic, inverse trig, polynomial, exponential, or trigonometric, which is why sometimes this is referred to under the acronym LIPIT. So our order is logarithmic, inverse trig, polynomial, exponential, and regular trigonometric. So for example, evaluate. We have x times e to x dx. Now, if we look back on that previous page, we have a polynomial here and an exponential here. So if we look, our polynomial is further to the left on the sliding scale, so our polynomial is going to be our u, while our exponential will be our e to the x. So we're going to say, so like I mentioned, this is u, this is going to be our v prime. So we know u is equal to x, while v prime is e to the x. Now, what we'll do is we'll figure out what u prime is, which our derivative of this is 1. And we already know what v is for this. Now, we know our integral of e to the x is just going to be e to the x. Now, we know that the integral would take the form of uv prime dx is equal to uv minus the integral of u prime v dx. So in this case, our integral of x e to the x dx is equal to uv. So we have u as x, v is e to the x, minus our integral of u prime, which is 1, times v, which is e to the x. Now we'll then do this integral. So we've got x e to the x minus our integral of e to the x, which is just e to the x. Then we've got plus c. Okay, next example, we've got our integral of x times cos 2x d of x. Now, this is a polynomial, this is trig. With our Lipit, trig is last, so we know that this is v prime, while this is u. So we have u is equal to x, and v prime is equal to cos of 2x. Now, our derivative of u would just be 1. Our antiderivative of v would be 1/2 times sine 2x. And once again, we'll follow our integral of uv prime dx is equal to ux, or sorry, uv minus the integral of u prime v dx. So we have the integral of x cos 2x dx is equal to uv. So x times 1/2 sine 2x. So we've got 1/2 x sine of 2x minus our integral of u prime v. So in this case, we've got 1 times 1/2 sine 2x. That gives us 1/2 x sine 2x, and then minus our integral of 1/2 sine 2x would be negative 1/4 cos of 2x. And we've got plus c. So we've got 1/2 x sine 2x plus 1/4 cos 2x plus c. Okay, so next we have the integral of x squared times the natural logarithm of x dx. Now with limit, we know that this comes first, our natural logarithm, so we know that this is u, well this is v prime. So we know u is equal to natural logarithm of x, while u prime would be 1/x. Now we know v prime is x squared, which means v would be 1/3 x cubed. So once again, we'll follow the format of uv prime dx is equal to uv minus our integral of u prime v dx. So if we have the integral of x squared times the natural logarithm of x dx, that's equal to uv, so that'd be 1/3 x cubed times the natural logarithm of x minus the integral of u prime, which is 1/x, times v, which would be 1/3 x cubed dx. So we'll simplify this a bit. So this is 1/3 x cubed times the natural logarithm of x. We can move 1/3 out front. So we've got minus 1/3 times the integral of x cubed times 1/x would be x squared dx. So that gives us 1/3 x cubed times the natural logarithm of x minus 1/3 times 1/3 x cubed plus c. So that gives us 1/3 x cubed times the natural logarithm of x minus 1/9 x cubed plus c. Okay, this brings us to I-cycle integration by parts. So our I-cycle pretty much is when we're doing this integration by parts and through cycling through, we end up back with our original integral. Now, we're going to look at the form of an integral of an exponential by a trigonometric function first. And typically, with these, we can end up, after just 2 cycles, ending up with our original integral. So we'll do an example of this and what to do when that happens. So for example, we have the integral of e to x sine x d of x. Now from Lipit, we know that u is going to be our exponential, which is e to the x, or v prime is going to be our trig function of sine x. Now that's going to make u prime e to the x, while v would be negative cos x. So if we have the integral of u v prime dx equals uv minus u prime v, or for integral of u prime v dx, we can say that our integral of e to x sine x dx is equal to negative e to the x cos x minus our integral of u prime v, so of negative e to x cos x d of x. Now we'll simplify this a bit. So this is negative e to the x cos x, and then we can move this negative out so it becomes plus our integral of e to the x cos x d of x. Now with this, unlike for previous examples we did where it came something we could simplify down to a single term, we can't, so we'll repeat the process again. So looking at this, our u would be e to the x, while v prime is cos x, which means that u prime is e to the x, while our v would be the integral of this, so sine x. So we essentially have negative e to the x cos x plus uv, so e to the x sine x, minus the integral of ex sine x d of x. So you can see we've now got this, which is what we started with. So what we're going to do is say let I, hence why it's called an I cycle, equal our integral of e to the x sine x dx. So that means that the left side of our equation is equal to I. So we've got I equals negative e to the x cos x plus e to the x sine x minus I. Now we'll add I to both sides to move this to the other side. So that gives us 2 times I is equal to negative e to the x cos x plus e to the x sine x. Now we'll simplify this a bit. So we'll divide both sides by 2, and both of these have e to x, so I'd factor that out. So that gives me e to the x times sine x minus cos x over 2 is equal to that original integral. Now we have something known as repeated integration by parts. So it's for when we have integral of a polynomial times a trigonometric function, or if integral of a polynomial times an exponential function. And for it, essentially, our integral of u v prime dx is equal to u times v1 minus u prime v2 plus u double prime v3 plus u triple prime v4 and so forth. So one thing you'll notice is in the first part, this remains unchanged. While to go from here to here, we are taking the integral. And then going from here to here, we'll take a derivative. While going from here to here, we're going to integrate again. And then going from here to here, we'll take the derivative. While going from here to here, we will once again integrate. Going from here to here, once again, take the derivative. Well, this term, we are once again going to take the integral. Now you'll notice with both these, our u is that starting function, so it's going to be our polynomial. Well, our second function is going to be either trig or exponential. So if we have integral of x squared e to 3x, that's going to equal this original function unchanged times the integral of this function, so that'd be 1 over 3 e to the 3x. I will make that a bit neater. And then one thing I didn't note when we looked at this is you'll note that we start with a minus, then a plus, so it keeps alternating signs. But we start with a minus. So we've got minus, we'll take the derivative of this. So derivative of x squared is 2x times the integral of this. So that'd be 1 over 9 e to the 3x. And then, because this one was minus, this one's plus, derivative of 2x is 2 times the integral of this, so that'd be 1 over 27 e to 3x. And we no longer have an x to take the derivative of here, so we would be done at this point. So we would just go through and simplify. So this would be 1 over 3 x squared e to the 3x minus 2 over 9 x e to the 3x plus 2 over 27 e to 3x plus c.